Hi everybody, welcome to our video solution to problem 4 from quiz 4. In this problem, we're computing the curvature of a curve. So there's a pretty straightforward formula when we're given a curve which is parametrized explicitly, namely the curvature, which we denote by kappa of t, is going to be given by taking the magnitude of the derivative of r cross product with the second derivative of r, and then divided by the cube of the magnitude of r prime. All right, so there's a lot of little components we have to work out, but ultimately it's a fairly straightforward formula. So let's work all these things out here. So how about we'll start with r prime. So r prime of t, we're just going to be taking the derivative component by component. So derivative with respect to t will be 1. Derivative of t squared is 2t. And the derivative of 1/2 t squared is going to be just t. All right, and you know we're going to need the magnitude at some point, so we might as well compute that while we're at it. So the magnitude of r prime, that will just be the square root of the sums of the squares. So we're going to get 1 plus 2t quantity squared plus t squared, which is, well, let's see, 2t quantity squared is 4t squared, and then you have another t squared, so we'll end up with 1 plus 5t squared. All right, let's see, what else do we need? We need r double prime. So we take another derivative, this time of r prime. We'll get 0 in the first component, and then 2, and then 1. And taking the cross product of these, which is what we'll need next, that looks like it should be pretty okay. So for the first component, we cross off the first line, and we'll do 2t times 1 minus 2 times t. Well, that's 2t minus 2t. That's actually going to be 0. To get the second component, we're going to cross off the second vertical line here, and we go backwards. We get t times 0, which is 0, minus 1 times 1. So 0 minus 1 will be negative 1. And then finally, we're going to cross off the last column, and we'll go back to left to right here. So we'll go 1 times 2, which is 2, minus 2t times 0, which is 0. So 2 minus 0, which is 2. So this is lovely. We actually are going to end up with just some number here. All right, and we want to take the magnitude of it. So we'll take the magnitude of 0, negative 1, 2, and that will end up being the square root of 0 squared plus negative 1 squared plus 2 squared. Okay, so let's see, we have 1 plus 4 is 5. So we get the square root of 5. And so our curvature is going to be the square root of 5 over, well, let's see, we need to cube this magnitude. So we might as well write this as to the 1/2 power, so then I can cube it, and I have 1 plus 5t squared to the 3/2 power. So it will definitely depend on t because of this t in the denominator, but now we know that we can get a curvature, right? And you can say things like, for example, as t goes to infinity, this denominator grows, and so since we have a constant on top, the curvature will actually be going to 0, which means the curve in the long run is going to start to look like a line. So that's kind of an interesting conclusion.